Hello everybody and welcome to day 9. These are the solutions for this week. We had 2 different 10 question quizzes going on for the first 2 weeks, and then we're entering probably another 2 to 4 weeks of these same kinds of solutions. So this is day 9, the new set of solutions that I'll refer to. Bless me. Alright, let's get into this. So, the first problem is going to always be one of the questions that we know how to do already. So in the very first set here, it's 7/5 plus 1 over 3. Now that would be the same, we would do the same thing as if it was minus, right? So if it was minus or plus, what do we have to do? Well, we have to have a common denominator. So that means that these both transform. What's the lowest common denominator here? You could do this multiple ways. 5 and 3 is 15. So these would be equivalent to the plus or the minus, something over 15 plus something over 15. Now, the something over 15 is 5 times 3 got us to 15. So if we had to times 3 here, then we have to times 3 by the top. 7 times 3 is 21. So 7 over 5 is the same thing as 21 over 15. So what do we do over here? Well, if this was multiplied by 5, this is multiplied by 5. So that means this is 5. So we've now converted this to the same denominator, and now we can do this. So of course we just add the tops at this point, and that equals, if I have 21 pieces of a 15 pizza plus 5 pieces of a 15 pizza, that's going to be 26 pieces of a 15 piece pizza. So that's the answer there, 26 over 15. Now, if we were going to subtract, that would actually, those would be the same, because we just have to put them over a common denominator. Sorry, and that's a minus. And so we would just take that away, and that would be 16 over 15. And that would be our final answer, if those were minused. So, you're going to also see questions in here that are the other fractions, right? So 1/2 times 1/3. Well, that you just go straight across on both, and we get 1 over 6 because we multiplied the top and the bottom. Now what if we have to go 1/2 divide 1/3, and I know you know this one, you flip and multiply. So that's the same thing as 1/2 times, flip this second fraction, 3 over 1. And then you multiply straight across, and you get 3 over 2. So these are each the addition, subtraction, multiplication, division of fractions. You'll see those in the first questions. You'll also see the conversions from fractions to decimals to percentage. And again, when you see those kinds of questions, don't forget that the decimal is to percentage is you times 100, going this way. So meaning if the decimal is 0.2, then timesing 100 means that you're moving the decimal point twice. So that's once, twice. There's a 0 there. That's 20% is the same thing as 0.2. And in the fraction, you take the percent and you put it over 100. So the fraction is just 20 over 100. So that's the easiest way to do things. You can do it backwards, right? If you started with something over 100, that something would be the percentage, and then you just move the decimal point twice over here. So those are the kinds of questions that you'll get. I might give you a curveball every once in a while, but that should be pretty obvious. And there are other solutions videos and other tools out there that you can work with. So that'll be question 1. Question 2, I'm going to stick to the combination of different terms. So in this question, I have 1 plus 1 plus x plus x plus x squared plus x squared. So this is again just to show you that there are different terms here. There are 6 terms, 1, 2, 3, 4, 5, 6, but 3 sets of 2. So these two, and these two can be combined. So 1 plus 1 is 2, plus x is 2x, plus x squared. Well, you might think that's like 4x squared or something, or x to the 4th. No, it's not. This is a different variable, it's a different thing. And so it's 2x squared. It's the same logic throughout all of these. I got 1 and 1 of these things, I can add them together. I got 1 and 1 of these things, I can add them together. I got 1 and 1 of these things, and I can add them together. So in the end, there's that, or you can rearrange to get 2x squared plus 2x plus 2. And there you have it. That's the answer to question 2. And again, combine those like terms. Find those pairs or those triples that allow things to come together. Question 3. Now, these are exponents. These are really important to know. So if I have 10 to the 6th, well, that equals this many zeros, right? So a 1 plus 6 zeros. That's 3. That's 6. Again, you backtrack, you write a comma after the 3, you write a comma after the 3. That's 1 million. So what did I do here? Well, I took this 6 and I counted 6 zeros after. That's with 10. Now the question that I asked was 100 to the 6. Well, what do we do on that? Well, this is kind of like 10 squared, right? 100 is like 10 squared. And so if I have that to the 6, well, there's this cool sort of rule in exponents where 2 times 6 is 12. That equals 10 to the 12. So what I did there was I used an exponent rule to change the 100 to a 10 squared, and then use an exponent rule to do that. And that, I just count that many zeros, so if I really wanted to write this out, it would be 1 with 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Whoa. If those are millions, those are billions, that's a trillion. That's a trillion written out there. So, careful with your exponent rules. Always kind of be watching for different exponents and what they mean. And remember that exponent with a 10 as your base, so 10 to the exponent means that you count the number of zeros in the exponent. So that's the trick to those kinds of questions. And in question 4, I gave you so I guess I'll write 4 over here, just so you know where we're at. I probably should have been doing that the whole time. X squared times, or to the 6th, well, that looks very familiar, what I just did in the previous problem. And the rule is, when you've got something inside a bracket to a power, that bracket means these multiply. So that's the same as x to the 2 times 6, which is 12. That's literally the answer. If that had been 10, right, then it would be 10 to the 12. And instead I substituted that in the previous question for 100. So when you see a bracket, you multiply those two numbers. It's really as simple as that. That would be different than like x to the 7 times x to the 7, right? There's no bracket there. So you add those exponents. That would be x to the 14. But just to bring it back to this example, if I had gone x to the 7 to the 7th, what would that be? Well, that would be multiply those exponents now with the bracket, and you'd have x to the 49, which is a very large number. Or very small, depends on what x is. That's the power of math right there. Alright, the next question is a new triangle, but same concepts. You can use any triangle, but this one is 1, 1, root 2, and these are both 45-degree angles. This is a very famous triangle. It's basically what happens if you cut a square in half, right? Because a square of 1, 1, 1, and 1 all has right angles. If I cut it like that, I get this triangle. So 1, 1, and this is root 2 here on this side. So the question I asked was sine of x. So sine of some angle equals opposite over hypotenuse. Cool. So sine of 45 degrees in this triangle equals what? So 45 is here, but 45 is here as well. Those are the same. So opposite would be 1 over root 2, but just looking, the same answer applies for 45 degrees here, 1 over root 2. So no matter what, the answer is 1 over root 2. And that'll be consistent. If you ever have the same answer here, it means that's okay, right? 45 degrees, you can pick either of those angles. They both end up being the same thing. So the answer to that, sine of 45 degrees equals what? It equals 1 over root 2. So that's the answer there. That would be the same. So if I gave you sine of something equals 1 over root 2, then that would of course be 45 degrees. So you're just using the new triangle to trace back, well, if opposite and over hypotenuse, this is the angle here that we're referring to. So that's question 5. Question 6 is the same as always. X plus 7 times x plus 7. Well, there's going to be 4 terms, x squared plus 7x plus 7x plus 49. Now I've done so many of these in my life that I can just see this and jump to the next step. So x squared plus 14x plus 49. So as soon as I see this, I know that I have to add these two to get 14, and that I have to multiply these two to get 49. The more of these that you do, the more that you'll just like not even, or just be able to skip over this step. And the tricky part to watch is if these are negative. If one of these or both of them is negative, that's going to translate through, and that's going to change this number the most, and this sign. That number changes radically. So let me just show you an example of this. So let's just pause on this chunk, and I'm going to make this minus. When I make this a minus, I get x squared plus 7x minus 7x minus 49. So you'll see this sign changed right there, and then this actually turned into 0x. So my final answer is x squared plus 0x, which we don't even include, minus 49. So you'll see that negative sign influences that middle number, and it influences that plus sign. So just be careful about those negative and positive signs. All right. So getting into the quadratic stuff. Questions 7, 8, 9, and 10. Well, questions 7, 8, and 9 are all about graphing. So let's just go over that. Y equals x squared. This graphed, and you can do this online, looks like this. So that U-shaped graph that touches right at the vertex, that is the simplest form of this graph. And we're going to move this around, so at some point, you know, This is upside down and really wide down here. We're not going to do that yet, but just be ready for that. And so, what are the factors? How did I do this? Well, I can set a t-chart. And that's really the easiest way until you get used to this. If you pick x, what's y? If I say x is 0, 0 squared, y equals 0. If I say x is 1, 1 squared is 1, y is 1. But if I say x is negative 1, y is also 1, because negative 1 squared, a negative times a negative. If you do a bad thing and then someone else does a bad thing, it equals a good thing. So, that is that. And then I can go up here and I can continue to sort of fill out this chart. And I know this quite well. And so once I fill out this chart, I can plot that on here, and I can plot those points, and I can fill this out. That's literally what you have to do until you get used to exactly which points this goes through. You have to list out the t-chart of at least 6 values, and I would go 0, plus 1, plus 2, and minus 1 and minus 2, always, just to see what's going on. So, the second part of this question, question 8, so that's the graph of this. Always do the t-chart with this. You have to do this list. Where is the vertex? Well, the vertex means the minimum point. It means, or the point where it changes direction. That's right there, and for this one, it's 0, 0. Again, this is the x-coordinate, this is the y-coordinate, and it's this point here. 0, 0 is how I would write that. That is the answer to question 8. Where is that vertex? So, find any other point on this graph. Well, you already did right here. So another point on this graph is 1, 1. That's from this. Another one is actually negative 1, 1. You listed out those points here. So just pull any one of those, and that's your answer to question 9. Now, the last doozy of a question is the quadratic formula. This is kind of like the power tool of quadratics. You bust it out when you can't get anything else going, or you can't understand how to do a problem. B squared minus 4ac all over 2a. I memorized this in about grade 10. Well, 9 into 10. I wondered at the time why I was memorizing this, and it's simply because this is like a power tool. And here's why. In the expression ax squared plus bx plus c, these values, c, this last number, only goes here. A goes here and here. B goes here and here. When you plug all those values in, you find a solution for x, which is kind of wild. And this has to be set to 0, actually there. So, or it can be y. Let's just put it as y for now. Basically, if something looks like this, if you have a number x squared plus a number x plus a number, you can put it in this form. So I could do like negative 2x squared plus 0.01x plus 3.68 equals y. That would be annoying because I'd have to use this as b, and I'd have to use this as c, and this as a. And that negative counts, right? The negative a has to be factored in. But you plug in all of those values. And so super quick, in the question that I gave you, where a equals 1, b equals 4, and c equals 4, you'll see I gave you these on purpose, because b squared is 16. Let's do in that space there first. Alright, so we've got negative b plus or minus the square or square root of all of this stuff. B squared is 16 minus 4 times A. A is 1 times C is 4. And you see what I did here. The square root is 16 minus 16, which is 0. So I end up getting negative b plus or minus 0, so we just leave that off, over 2 times 1, which is 2. And I put in b, which is 4. So negative 4 all over 2 equals negative 2. Negative 4 over 2 is negative 2. So that is the answer. X equals, when A equals 1, B equals 4, C equals 4. You just plug in those numbers. And you have to take a square root of that, but if that turns out to be 0, then you don't have to do anything, right? Because the square root of 0 is just 0. So this week I'm going to make that be 0, but if that turned out to be 9, right, under that square root, then the square root of 9 is 3. So you'd have negative b plus or minus 3, and so you'd literally have 2 answers. You'd have one when it's plus and one when it's minus. That's the tricky part about this, that at the end of the day, x can equal 0 things, it can equal 1 thing, or it can equal 2 things. And I'm giving you solutions this week where there's one answer, because that like cognitively makes the most sense. But if the square root is a negative, then there's no things. And if the square root is some random number like 3, you're going to have 2 things, because you have to have negative b plus or minus whatever that is, which is going to get you to 2 answers. So there's lots of videos on this. This is called the quadratic equation. We're going to solve this. I'm just going to keep giving you these numbers, A, B, and C. You're just going to plug them in to this big old complex formula that you're going to memorize, because this is like a power tool when it comes to solving these. So I hope that's helpful. There you go. Those are all the solutions for this week, and thank you very much.